Astronomers estimate there are 100 million wandering stellar corpses, black holes cast into space by the explosions that made them, lurking among the 100 billion stars of our Milky Way galaxy. And now scientists have captured imagery revealing what appears to be one of these cosmic zombies, as it crossed paths with a more distant star. Hubblesite.org, which announced the news on Friday, June 10, 2022 said, "Following 6 years of meticulous observations, the Hubble Space Telescope has, for the first time ever, provided direct evidence for a lone black hole drifting through interstellar space by a precise mass measurement of the phantom object. Until now, all black hole masses have been inferred statistically, or through interactions in binary systems or in the cores of galaxies. Stellar mass black holes are usually found with companion stars, making this one unusual. Astronomers believe the object is the first dark stellar remnant discovered wandering through our galaxy, unaccompanied by another star. How far away is the black hole? The astronomers aren't sure exactly how far away this black hole might be. Their statement explained. The newly detected wandering black hole lies about 5,000 light-years away, in the Carina-Sagittarius spiral arm of our galaxy. However, its discovery allows astronomers to estimate that the nearest isolated stellar mass black hole to Earth might be as close as 80 light-years away. By comparison, the nearest living star is Proxima Centauri, and it is 4 light-years away from Earth. Some ways of detecting black holes. Because black holes cast no light of their own, astronomers typically hunt for their effect on visible matter. The stellar mass black holes discovered in the galaxy before this one are all only noticeable because they're in binary systems. The black holes pull matter from their companion stars, and the incoming matter forms a disk around the black hole. It's this accretion disk that astronomers typically see when studying stellar mass black holes. In recent years, astronomers with the Event Horizon Telescope, EHT, have also begun to acquire images of supermassive black holes. They've managed 2 so far. The first, announced in 2019, shows the supermassive black hole in the galaxy M87, some 55 million light-years from Earth. Then, just last month, May 2022, astronomers with the EHT announced the first ever direct image of the supermassive black hole at the center of our Milky Way galaxy. It's about 28,000 light-years away. By the way, the EHT images don't show the black holes themselves. Black holes are, by definition, black because no light can escape them. So black holes themselves are invisible. Instead, the EHT images show what astronomers are calling a black hole's shadow, a bright ring formed as light bends in the intense gravity around the hole. Lone black hole found by gravitational lensing. But this new black hole isn't in a companion system. And it's not a supermassive black hole, and therefore not massive enough to be observed by the EHT team. Torn out of orbit by the enormous blast that created it, the black hole detected by Hubble was seen as it passed in front of a more distant star. That is, the scientists used gravitational lensing, the bending of a distant object's light by a massive object in the foreground, to capture their evidence. The scientists who made the detection said, "The light from a star far behind the black hole was momentarily brightened and deflected by the black hole passing in front of it. This was a long and painstaking measurement that the Hubble Space Telescope's exquisite resolution is well suited for. The black hole's powerful gravitation left a unique fingerprint on the deflection of starlight, eliminating other potential gravitational lensing candidates. The lensing event took 200 days. The scientists said the duration of the lensing event helped convince them the object is a black hole, and not something else. The very intense gravity of the black hole will stretch out the duration of the lensing event for over 200 days. Also, if the intervening object was instead a foreground star, it would cause a transient color change in the starlight as measured, because the light from the foreground and background stars would momentarily be blended together. But no color change was seen in the black hole event. So the signature of a foreground black hole stands out as unique among other microlensing events. The scientists also commented that the Hubble Space Telescope is making these measurements very precisely down to the millisecond range, making it extremely well suited for this particular observation. The announcement from Hubblesite.org put it this way: That's equivalent to measuring the diameter of a 25-cent coin in Los Angeles as seen from New York City. Could it be a neutron star? A pair of teams at the University of California, Berkeley, and the Space Telescope Science Institute in Baltimore, Maryland, made the black hole discovery. The object they measured has a mass that falls in a range between 4.4 and 1.6 solar masses. The lower end of that range means the object could be a neutron star. The announcement quoted Jessica Lu of the UC Berkeley team. As much as we would like to say it is definitely a black hole, we must report all allowed solutions. This includes both lower mass black holes and possibly even a neutron star.